Hello everyone, and welcome to our very first lesson of Chapter 9, which is about simplifying radicals. So before we can even get into the geometry of Chapter 9, we have to master and conquer this skill. And so we're going to be simplifying radicals today, and we're going to do like a little intro activity in class to talk about what perfect squares are. Many of you are very familiar with those, so we're going to examine perfect squares before we look into, well then, what is going to be the non-perfect squares. I'm going to give you the how-to on non-perfect squares. So if you were to start and just type both of these into your calculator, whenever you type in the square root of 196, it's going to give you a whole number. It's going to give you 14. The radical symbol goes away, and this is exactly 14. Whereas I'm going to have y'all start class by doing this. Type in the square root of 75 into your calculator. So go ahead and type that in. When you type in the square root of 75, the square root of 75 is going to give you a decimal. It's 8.6602540.3, and it just keeps going. And so that is going to give us a non-perfect square. And so we're going to learn today, our goal before you leave today is going to be to learn how to simplify this type right here. But we do that by examining what perfect squares are. And so we know the perfect square that is going to give me 1, we could get to go this way, you're going to square it. So 1 squared is just 1. So the square root of 1 is 1. Those are inverses of each other. Taking the square root is the inverse of squaring. So what is going to give me the whole number 2? Well, 2 squared is 4. And so I'm just going to fill in this list, okay? So 3 squared, you could type this in your calculator. 3 times 3, it's going to give me 9. 4 times 4, 16. We just go all the way down. 5 squared is going to be 25, then 36, then 49, then 64, then 81, 100, 121, 144. 13 squared is 169, while 14 squared is 196. 15 squared is 225. 16 squared is 256. So usually if you know about to here, you're pretty solid on most of the problems that we work with in geometry, but we're going to go all the way up to 25 for the purposes of our notes. So 17 squared, when you do 17 squared, that's 17 times 17, that's going to give you 289. 18 squared is going to be 18, you can just type that in if you need to, is 324. 324. 19 squared is 361. 20 squared, this is a good one to know, is 400. Square root of 400 is 20. 21 squared is going to be, let me make sure I've got that right, 21 is 441. Okay. 22 squared is going to give me 484. 23 squared is going to be 529. 24 squared is 576. And then 25 squared is going to be 625. That's a good one to know as well. So really, as long as you know to about here, you're solid. But it is good to know 20 squared is 400, and then 25 squared is 625. Okay. All right, y'all. So what we're going to be doing today is finding how to simplify non-perfect squares, or non-perfect squares. And so, like I said, we have this square root of 196, give me a whole number, it's 14, so that means it's a perfect square. But when you type in the square root of 75, it gives you a decimal. So here's how I'm going to kind of explain this. If on a test, if you left an answer as 6/10, you would get counted off for not fully simplifying. You'll tell me this all the time, oh, it's just not fully simplified. Well, what is 6/10 equal to? 6/10 simplifies to 3/5. While both of these are 0.6 as a decimal, this fraction form is more simplified than the 6/10. So that's been fully reduced, okay? Yes, they're both equal to 0.6 as a decimal, but the form 3/5 has been simplified from 6/10. So that's going to be the same thing as what we're doing now. What I simplify the square root of 75 to is still going to have a radical in it. It's just going to be a more simplified radical than the square root of 75. So let's examine how to do that. Let's go to our how-to. Here's our 1, 2, 3 steps for the how-to. The first thing you're going to do is you're going to find the perfect square factor, and I'm going to add a word up here. It will save you time if you find the biggest perfect square factor that the number is divisible by. If you find the biggest, that is a time saver, and you won't have to resimplify and resimplify. Then you're going to rewrite it as the square root, the radical, square root of that perfect square times the non-perfect quotient. The perfect square is going to simplify to a whole number. Perfect square is going to simplify to a whole number, while the quotient will not, and it will remain under the radical symbol. So it says if it is not divisible by any perfect squares, that just means it's already in simplest form. So like if I gave you the fraction 1/3 and asked you to simplify it, 1/3 is just 1/3. And so that's already in simplest form, okay? And so you would just rewrite the radical if there's no perfect squares that I can take out, okay? All right, so what we're going to do is we're going to find the biggest perfect square that the number is divisible by. So if I'm looking for to break the square root of 75 down into its factors, some people will do this with factors trees, especially in middle school. You see a lot of factor trees. We are not going to use that method. We're going to use this perfect squares list in order to help me look for more quickly what I'm trying to break this down into. And so square root of 75. I always make myself draw a little line here to say I know that nothing bigger than 75 is going to be a factor. So instead of having to check all of these, this breaks it down to just having to check this 1, 2, 3, 4, 5, 6, 7 or 8 numbers instead of all of them. And so if I do 75 divided by 64, that's going to give me a decimal. So that is not a factor. It is divisible by 64, but it is not a factor of 75. And so I'm just going to keep going. The first one didn't work, so I'm going to slow down at the very beginning of this process. The first one was not a factor. Then 75 divided by 49, that's not a factor. 75 divided by 36 is not a factor, but the first one that works. Ding, 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 we have a winner. The first one that works, the 25 is a factor of 75. So when I rewrite this, I can't just change this to the square root of 25. When you're in a store and you see a price tag, you can't just make it cost less. But I can rewrite this in a different form. This is going to be the square root of 25 times the square root of what? What is 75 divided by 25? Square root of 3. Okay? So we have rewritten this as the product of the perfect square times its quotient. So square root of 25 times the square root of 3 is still the square root of 75. It is just written in a different form. Okay? So why do we like this, having this square root of 25 here? Well, the square root of 25 is a perfect square. What was the square root of 25? It tells us it's the whole number 5. 5 times 5 is 25. So this one simplifies, while what's remaining does not. Square root of 3, that's fully simplified. Since I found the biggest perfect square factor, I won't have to simplify that twice. So the square root of 75 simplifies to 5 root 3. How can you check and make sure that you did it right? Earlier, when we typed in the square root of 75, we got that long decimal. Square root of 75 was 8.6602, blah, 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 blah. If you type in 5 times root 3, you're also going to get this exact same decimal. We have just written this in more simple form. So this is simplified. And as long as you get the biggest perfect square factor, you won't have to do this more than once. So that's why we're always going to look for the biggest amount. Okay? If not, you would just have to resimplify the radical every time. All right, so we're going to do this a few times. We're going to practice this. And so square root of 27. Here's the good thing. When you have smaller numbers, there's less values you need to check. So I'm going to erase this amount. And so square root of 27, where does that fall in my list? It falls between the square root of 25 and the square root of 36. So immediately, the reason I want y'all to think like this, immediately I know as a decimal, this is going to be 5 point something if I typed it in. It's not going to be a perfect square. Okay, it's going to be 5 point something. And so I know that I need to write it in simplest form is what the directions say. So the first number I'm going to check is 25, and then I'm just going to go up the list. Because again, I'm looking for the biggest perfect square factor. 27 divided by 25 gives me a decimal. 27 divided by 16 gives me a decimal. So I'm just going to cross these out as I go. 27 divided by 9, gives me a whole number. 27 divided by 9 gives me 3. So I'm going to rewrite this. I'm going to work with colors. My perfect square is the square root of 9. And then I'm going to multiply that by square root of 3. Again, I've just broken this apart. It's kind of like saying 6 is the same thing as 2 times 3. 27 is the same thing as 9 times 3. Both of these are just under a radical. So what was the square root of 9? What can I simplify that to whole number-wise? That becomes 3. That one does simplify. Square root of 9 is 3. The whole number pops out. But what has to remain under the radical symbol? That root 3. So our final answer would be that the square root of 27 simplifies to 3 root 3. Again, you can type that in and see that those are the exact same decimal value. We've just rewritten the radical in simplest form. Okay, so let's keep going down the list. I'm going to 78. So again, I'm going to be writing this list at the top of almost every assignment we have. So 78, where does 78 fall? 78 falls below the 64, so it's going to be 8 point something as a decimal. And so again, I just go up this list. We're looking for our biggest perfect square factor. If there are any, great, it gets to simplify. If not, then it's already in simplest form. So again, I start doing 78 divided by 64 gives me a decimal, 78 divided by 49. The very first factor that is going to give me, 36 is not, 25 is not, 16 is not, 9 is not, divided by 4 is not. Now 78 divided by 1 is going to give me, 1 technically is a perfect square, but let me show you why we don't do that. If I were to write this as the square root of 1, that is a perfect square, times the square root of 78. Square root of 1 is just 1. 1 root 78 is the same thing as just root 78, okay? So that doesn't help me. And so what this means is that this is already in simplest form. Oh, goodness, wrong thing. What I'm going to do is I'm just going to say, hey, the only one that worked was a 1. So this is already in simplest form. That's like saying I can't simplify 1/3 any. I can't simplify the square root of 78 any. Okay, already in simplest form. So let's go again, but instead of 78, now we're going to try 72. So I start at the same spot. Let's start crossing out what doesn't work. I go up the list looking for the biggest perfect square factor. Ooh, 36 does work. 72 divided by 36, ding, 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 we have a winner, is 2. So let's write that out. Square root of 36, that's the perfect square, times the square root of 2. So which one was perfect? The square root of 36. What is the square root of 36? It's the whole number 6. So that simplifies to a whole number, while the 2 remains under the radical. So 6 root 2 is my final answer. Okay, let's keep going. This is the square root of 63. So this falls, we get to move up the list a little bit, 63. Okay, so 63 falls here. Again, this is just helping me save time for not having to resimplify over and over again. I'll show you an example in a minute of what you would have to do if you had to resimplify every time. And so we're going to go up this list. 63 first divided by 49, decimal. 63 divided by 36, decimal. 63 divided by 25, decimal. The first one that's going to work for this one is going to be the square root of 9. So I can rewrite this as the square root of 9 is the perfect square times the square root of 7. So I'm always going to write my perfect square first. Because what I'm trying to do is I'm trying to simplify that. So what is the square root of 9? Square root of 9 is 3. So that simplifies to the whole number 3. What remains under the radical symbol? 3 root 7. 3 root 7. Okay? So I'm just going to keep going the same way. And we're not going to do every single one of these. I'm going to let y'all try a few in class. So my advice is if you're watching this later, or if you're watching the YouTube video, pause it and try a few and then click play and see how you did. So I'm going to stop referencing the list every single time, but I might just scroll up there. I'm not going to mark it up like I have been every single time. Okay? So you kind of know where to start based on what you're looking for. All right, so square root of 90. So again, I'm going to have to start here. I go up the list. I start at 81 and then go all the way up. The first one that's going to work for 90 that I got was the square root of 9. So square root of 9 times the square root of 10. Again, this is still the square root of 90. I've just written it differently. Why have I written it differently? The goal is to simplify this perfect square. So what's the perfect square? Square root of 9, it tells us. Square root of 9 is 3. So that becomes 3. What remains under the radical? The root 10. So 3 root 10. Gives me a whole number coefficient with the remaining radical as root 10. All right, now I am going to show you this, 175. So just to show you that this list, there's a lot more I'm going to have to check on this problem. So the bigger the number is, the more numbers you're going to have to check, which makes sense because our factors are going to get bigger as well. So here's where I start, 169, and I just go up the list, okay? So 175. The first perfect square factor that is going to be divisible by 175, as far as giving me a whole number, is going to be the square root of 25. It's going to be the square root of 25 times root 7. Times root 7. Why does this help me? Because the square root of 25 is a perfect square. The square root of 25 gives me 5 as a whole number. And then again, this remains under the radical symbol. Okay. So I want to pause here and give you an example of why we are going to always look for our biggest perfect square factor. It is a time saver, y'all. It is our biggest perfect square factor. So many people will get familiar with this list as we make it. And a lot of people start small, like they start with the smaller numbers. And so someone may look at this list, and instead of starting at 162, so instead of starting way down here and going up the list, if you were to go the other way, let's see what would happen. Let's say if we went down the list instead. So if we went down the list, when I'm finding factors of 162, a perfect square factor that goes into 162 that's smaller, the first one I would hit if I went this way would be the 9. So that'd be the square root of 9 times the square root of 18. So you simplify the square root of 9 and you get 3, but let's watch this. You go to simplify the square root of 18 and watch what happens. Square root of 18 can be rewritten as the square root of 9 times the square root of 2. So then we have to simplify the square root of 9 again. So then that becomes 3 times whole number 3 times root 2, a non-perfect square. 3 times 3, that's going to simplify to 9, and then that would be 9 root 2. So that was a whole bunch of work because I had to simplify first, and then I had to re-simplify. Watch when it's faster when I go the other way. If I go up the list instead of down the list, watch what happens and how much quicker this is. When I start going up this list, the square root of 162, the first one that I hit that works is 81. Okay? So when I rewrite this as the square root of 81 times the square root of 2, I found the biggest perfect square factor there. Square root of 81, boom, is 9, and I'm left with 9 root 2. So I don't have to simplify more than one radical if I look for the biggest perfect square factor. Okay? So that's why we go up the list instead of down the list. All right, square root of 28. The first one that works for 28, I start here, 28, and I go up the list, and the first thing that works is going to be 4, square root of 4. So that's the square root of 4. It's the perfect square. That's going to be times 7. It's times the square root of 7. Root 4 times root 7. Why does that help me out? Because the square root of 4 is 2, and then that is a fully simplified square root of 7, so 2 root 7. Okay? 225. Now, I first look at this and I'm like, oh, 25 goes into it. But 225, I actually notice is on my list. That's also why I want to reference my list. And I always like to draw where I'm starting. Like y'all can see I do this over and over again of kind of putting like a home base. Because right here, square root of 225 not only falls between my list, it's on my list. So what is the square root of 225? It's perfect. Boom. It's 15. So if I wanted to rewrite this and kind of color code it how I have been, square root of 225 is already perfect. What is the square root of 225? It's perfect, it's 15. Okay? So there's nothing left under the radical, in other words. All right, 450, I know, so this is an example. I know for sure that 25 goes into 450. I always think about this kind of like money. So I know that 25 would be a factor, but the question is it the biggest? So that's why we go on this list. And we say, okay, 450 would fall here. So what's the first perfect square factor that's going to give me a whole number? Actually, it is going to be 225. 225. So 450 can be broken into 225 times root 2. Okay? Because what is 225, the square root of 225? That is going to give me whole number 15. Okay? So what remains under the radical? Root 2. So my final answer, fully simplified, square root of 450 would be 15 root 2 is how you read that out loud. So where does 343 fall on the list? 343 falls here. So again, I'm just going to go up that list. When I finally get there, the first one that's going to give me a whole number when I'm doing 343 divided by each of these is going to be 49. Okay? So that is going to be the square root of 49 times the square root of 7. Of course, we know that the square root of 49 is whole number 7. So that's going to be 7 root 7. 7 root 7. We already did square root of 27 on number 1, so we're going to skip that one and go ahead and go to 70. So at this point, if you're on the video, pause it and see if you can do a few of these on your own. All right, so what is the square root of 70 going to simplify to? I come over here, and this always makes me uncomfortable. I come over here, and I'm like, okay, where's 70 at? 70 falls here when I'm looking at my factors. Narrows it down to this. Divided by 64 gives me a decimal. I'm going to start crossing things out. Divided by 64 gives me a decimal. 70 divided by 49, decimal. 70 divided by 36, decimal. 70 divided by 25, decimal. 16, decimal. 9, decimal. 4, decimal. If the only one that works is the 1, that just means it's fully simplified already. So square root of 70 is just simply the square root of 70. That is a fully simplified non-perfect square. Okay? I hope that you'll start to get better with this list as we work with it more and more, and so you won't have to reference it quite every time. So the square root of 32, while I know that 4 goes into 32, a bigger perfect square that goes into 32 is 16. That's the square root of 16 times the square root of 2. Square root of 16 is 4. I like to circle the perfect square. Square root of 16 is 4, and so this becomes 4 root 2. Just a time saver. What is the square root of 100? Well, it's already perfect. Square root of 100 is just 10. Boom, we're done. No radical symbol. All right, 117. 117 is always one that I get tripped up on, so let's pause it and see. Let's go back and reference our list. So where's 117 at? 117 falls between these two perfect squares, so it's going to be 10 point something. I know it's not 100, so I'm just going to keep going. I know it's not 81. I know it's not 64. You could keep trying this, and we're going to look for a perfect square that goes into it. So 117 divided by 36. And then 117 divided by 25. We know that's not right. 117 divided by 16. 117 divided by 9. Ooh, and it's 13. So this is one that I always want to say is prime, but it's actually not. And so it's going to be square root of 9 times the square root of 13. So what is the square root of 9? Square root of 9 gives me the whole number 3. So this becomes 3 root 13. 3 root 13. Okay? And you could type that in. If you weren't sure and you wanted to make sure it was right, type in the square root of 117, you get 10.8, 16, ... If you type in 3 and then you multiply that by the square root of 13, you're going to get the same thing. Okay, you're going to get the exact same thing. All right, 125, I'm hoping this will start to become quick for y'all. Square root of 125 is going to break down to 25 times, what would that be, 5? What is the square root of 25 that's perfect? That would be 5. What remains? 5 root 5. All right, and then last but not least, 80. Now this is tricky. 80 is a little bit different because when you first look at this problem, you might think, okay, well 4 goes into it. But let's double check and make sure that there's not a bigger perfect square. Okay, let's make sure there's not a bigger perfect square than 80, or than 4 that it's divisible by. Because right now, if I divided by 4, that'd give me 20. Well, 4 also goes into 20, so I know that that's not the biggest perfect square factor. What is a bigger perfect square factor? So I'm going to erase all of this, and for the purposes of this last one, I'm going to start fresh on my list, okay? Where does 80 fall? Boom, above 81, so we're here. When I go up this list instead of down this list, we already know that 4 is going to work, but is there something that works before that? Type them all in. Start with 64. We know that's not going to be it, but keep going. Ding, 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 we have a winner. When you get to 80 divided by 16, that's going to give you 5. So the biggest perfect square factor is not 4. That is a perfect square factor, but the biggest is going to be 16. Square root of 16 times the square root of 5. What is the square root of 16? Whole number 4. That gets to come out of the radical symbol. And root 5 remains, so that would be 4 root 5. If not, you're going to have to resimplify and resimplify if you don't find the biggest perfect square factor. So your assignment is going to be the Simplifying Radical Expressions design page, and all of these correspond. There are 25 questions and there are 25 boxes that you're going to shade in to correspond to the correct answer. So I will let y'all try that on your own, and we'll see how you did tomorrow.